Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we will be discussing Lecture 5 of Module 6. The topic of the lecture is Anticyclones, their origin, characteristics and associated weather conditions. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello dear learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun, Uttarakhand. In our previous lectures, which we have covered in Module 6, we have primarily focused on the cyclonic conditions, the formation of tropical cyclones, the formation of temperate cyclones, fronts, etc. But in this particular video lecture, unlike the other lectures, we will be covering anticyclones primarily, the origin of anticyclones, the characteristics of anticyclones, and weather conditions which are associated with anticyclones. So let's begin. In the due course of this particular video lecture, the learners will be able to understand various concepts related to anticyclones. So they will try to understand what are anticyclones. They will also have basic understanding of the formation and characteristics of anticyclonic conditions. And then what are the associated weather conditions with anticyclones. And finally, we'll be understanding what is the basic classification of anticyclones. Now, starting with the basic definition of anticyclones. What are anticyclones? An anticyclone is a weather phenomenon defined as a large-scale circulation of winds around a central region of high atmospheric pressure. So unlike cyclonic conditions where you have low pressure center and where winds rushes to this particular low pressure center, unlike this cyclonic phenomena, in conditions of anticyclone, you have high pressure at the center and you have decreasing pressure outwards, because of which the winds blow from the central region of high pressure towards the outer margins of low pressure. So surrounded by closed isobar, it has highest pressure at the center and the pressure decreases towards the peripheral regions, because of which the winds move out from the center of high pressure in a clockwise direction in the northern hemisphere and counterclockwise direction in the southern hemisphere as viewed from above, which is a situation opposite to cyclone, because in cyclone you have anti-clockwise wind movement in the northern hemisphere and clockwise wind movement in the southern hemisphere. But opposite from that, in an anticyclone you have clockwise wind movement in the northern hemisphere and anti-clockwise movement of winds in the southern hemisphere. Effects of surface-based anticyclones include clearing of skies as well as cooler, drier air. Again, opposite to the cyclonic conditions where you have frontal precipitation, where you have formation of clouds, where you have turbulence weather conditions, in the anticyclone, you have opposite conditions. You have clearer sky, you have drier air and dry weather conditions which are devoid of precipitation mostly. Besides this, fog can also be formed over within a region of high pressure. So as you can see in this diagram, this is a diagram of anticyclone as viewed from the satellite. You can see that in the central region you have very high pressure, because of which there is no formation of clouds and no movement of winds in the central core region of high pressure. And whatever winds blow, they blow from the central core region of high pressure towards the outer margins, which have comparatively lower pressure. So anticyclonic conditions mainly prevail because of two conditions. They can be thermally induced as well as they can be dynamically induced. So what do you understand by thermally induced anticyclones? When, because of very low temperature in the polar areas, very high pressure exists, it leads to the formation of anticyclonic conditions, which is induced because of the very low temperature conditions. So in the polar areas you have thermally induced anticyclonic conditions or thermally induced anticyclones. Besides thermally induced anticyclones, you also have dynamically induced anticyclones, which are mainly formed in the subtropical high pressure belt regions of the world around 30° north and 30° south latitudes in both the hemisphere, primarily due to the sinking of air from aloft in the subtropical high pressure belts region of the world. And these regions experience light wind movement at the surface and subsidence of air from higher portions of the troposphere. Because of the subsidence of air, the adiabatic warming of the air parcel takes place, which leads to the formation of dry conditions with less to no rainfall. So as we have discussed previously also in many videos, that if you have low pressure conditions at the ground surface, you will have high pressure conditions in the upper atmosphere. And vice versa to this, if you have high pressure conditions at the ground surface, you will have low pressure conditions at the upper atmosphere. So in these particular subtropical high pressure belt regions of the world, there is convergence of air in the upper atmosphere, which when accumulates sinks to these high pressure regions at the ground surface, and as soon as they hit the ground surface they tend to diverge. So these particular regions of the world are characterized by the divergence of winds, and because of the divergence of winds, when the air subside from the upper atmosphere towards the ground, it is adiabatically warmed up, which retards the conditions for the precipitation in these areas. Therefore, these areas experience dry conditions and very arid conditions because of divergence of air, leading to less to no rainfall conditions. Now let's just try to understand the dynamically induced anticyclonic conditions with the help of this diagram. So as you know that the equatorial areas of the world, because of intense heating, they have the low pressure conditions on the Earth's surface, because of which the winds from the higher pressure regions of the world are attracted towards this low pressure center, which is created in the equatorial regions of the world. And once the wind try to converge near the low pressure areas in the equatorial regions of the world, because of convection, these winds are carried aloft. So the rising air over the equatorial area is primarily because of the convection along the intertropical convergence zone, which is primarily because of intensive insolation. And these winds, once they ascend and reach in the upper regions of the troposphere, because of the presence of high pressure in the upper atmosphere above the equatorial low pressure centers, the winds tend to diverge in opposite directions. The divergence over the near equatorial trough leads to air rising and moving away from the equator to the polar areas in the upper atmosphere. And as the winds move towards the mid-latitudinal areas in the upper atmosphere, they tend to sink near 30 degrees north and south in both the hemispheres. And once these descending winds hits the ground surface, they tend to diverge in opposite direction again at the ground surface, creating subtropical high pressure in these 30° north and 30° south regions of the world. Besides this, subpolar low pressure belt also exists somewhere around 60° north and 60° south in both the hemisphere, which leads to the convergence of winds along these subpolar low pressure belt zones in both the hemisphere. And once the winds converge, they again ascend, and because of the presence of high pressure in the upper atmosphere, the winds again tend to diverge in the opposite directions. So one wing of the air move towards the high pressure zones in the polar areas, while the other wing subsides again at the 30° north and south in both the hemisphere, creating the high pressure zones. Anticyclonic conditions in these subtropical high pressure regions of the world, primarily because of the sinking of air which is descending from the upper tropospheric region in these areas in both the hemispheres. So sinking and divergence of wind from both the cells at the surface in this region forms the subtropical ridges, which are the zones of high pressure areas extending along the 30° north and 30° south in both the hemispheres. And because of these persistent anticyclonic conditions in these regions, many of the world deserts are also formed along these latitudinal belts of the world, since they are characterized by very dry weather conditions which are devoid of precipitation. So dynamically induced anticyclonic conditions is primarily formed because of the sinking of air near the 30° north and 30° south in both the hemispheres from the upper tropospheric regions, which reinforces the high pressure conditions in these zones, and they are characterized by the divergence of winds creating anticyclonic conditions lacking rainfall. So as you can see in this particular diagram also, that the area somewhere around 30° north and 30° south in both the hemisphere, that is along the Tropic of Cancer and Tropic of Capricorn, you have subtropical high pressure belt. And this high pressure belt is basically a subtropical high pressure ridge region also, because this entire belt demarcates the area of very high pressure, primarily induced because of the dynamic conditions where the sinking of air from aloft hits the ground and diverge into opposite direction, creating high pressure condition in these areas in both the hemispheres. And these areas of the world, because of these existing high pressure conditions and anticyclonic conditions, are mostly devoid of rainfall, presenting dry, arid conditions. Therefore, most of the deserts of the world, for example, the Sahara Desert, as you can see, Namib Desert, Iranian Desert, the Australian Desert, Atacama Desert, then you have the deserts in North America, are mostly found in this particular belt only. Besides these hot deserts of the world, you can also see that the extreme northern polar regions of the world, you have the Arctic dry zone, and in the extreme southern hemisphere you also have the Antarctic dry zone. Okay, so these areas are also very dry, chilly, cold areas of the world because again of the presence of anticyclonic conditions. But the anticyclonic conditions in these areas is primarily induced because of the thermal condition, and extremely low temperature in these areas creates the zone of high pressure along the polar areas in both the hemisphere. So you don't only have the hot deserts of the world along the high pressure belt of the world, because even in these regions of the world you have very less rainfall, and much of the precipitation which takes place, it takes place in the form of snow. So these areas are also devoid of precipitation in form of rainfall. So while these cyclones are typical regions of turbulent weather conditions, anticyclones or anticyclonic regions represents meteorologically quieter regions with less to no weather activities happening in those zones. And generally, these anticyclones are much bigger and larger than cyclones, and they exhibit persistent downward motion of air yielding dry, stable air conditions, and they may extend horizontally for hundreds of kilometers, bringing dry, arid, stable conditions to those zones where they occur. So anticyclones often represent the regions of clear skies and sunny weather conditions in summer, while at other times of the year during the winter season, they may bring very cold conditions and the region may be cloudy, foggy, and especially these conditions happen over the wet ground snow covered surfaces, and it can also happen over the oceanic surfaces. Now coming to the general characteristics of anticyclones. So as we have studied in the previous slides, these anticyclones are the region of high pressure. These are high pressure systems which have the highest pressure at the center and low pressure towards the margins, because of which these anticyclones are surrounded by the closed isobars with decreasing pressure towards the outer margins, and because of which the winds blow from the high pressure central regions towards the low pressure outer marginal areas, and the movement of winds is clockwise in the northern hemisphere while it is anti-clockwise in the southern hemisphere. And the frequency, the existence of anticyclones is most prominently observed over the subtropical high pressure belts of the world, which are found along the 30-degree north and 30-degree south in both the hemispheres. So they are most commonly seen in the subtropical high pressure regions of the world. And in these regions, the winds descend from above at the center and they diverge because of the existing high pressure at the ground surface. Since the region is characterized by divergence of winds at the ground surface, these regions have fair, rainless, dry, arid weather conditions, and the arrival of anticyclone in any region is marked by the clearing of clouds if clouds were existing previously in these areas. So suddenly there is clearing of clouds and clear weather persists with decreased wind velocity. So very light feeble winds they blow in these regions, because of which arid conditions prevail. Another important characteristics of anticyclone is that the wind system in these type of systems are not fully developed, and the center is characterized by light breeze, because you have cold conditions which exist in these areas. Therefore, the winds become stable, become more dense, and they subside, leading to the low wind velocity air blowing in these areas. And the tracks of anticyclones are also very variable. They move very sluggishly because they are very extensive systems. They mainly move very sluggishly, and sometimes they may also become stationary over a particular place, and the average velocity of anticyclonic movement may range from 30 to 50 kilometers per hour. Also, the shape of the anticyclone may vary. Usually they are circular, but they can be near circular or wedged, and sometimes they also can be of V shape. But these systems are definitely much larger in size as compared to the temperate cyclones, and the diameter of the anticyclone is nearly 75% larger than that of the cyclones, and the diameter may become somewhere around 9,000 kilometers also when these anticyclonic systems becomes very extensive. So the anticyclones originate primarily due to the descent of air, either polar cold air coming from the north or the tropical warm air mass coming from the south. Therefore, they are associated with the low temperature and they are indicative of dry weather conditions. Now, coming to the classification of anticyclones can be primarily classified into two types. First one is the cold anticyclone and second one is the warm anticyclone. So let's discuss them one by one. Cold anticyclones are primarily thermally induced because these types of cyclones generally originate in the northern polar regions of the world where the temperature is very low. So they originate over Arctic regions or the polar areas of the world primarily due to very low insolation and very low temperatures, which induce very high pressure, especially in the winter season along these higher latitudes of the world. So in most cases, an actively developing anticyclone may also form over a ground location in the region of cold air behind a cyclone also in the higher latitudes. So this anticyclone forms before the next cyclone advances into the area, and such anticyclone is also called as cold anticyclones. So they are primarily developed in very high altitudes, generally extending between 70° north and 70° south to 90° north and 90° south in both the hemispheres. And once they develop, they advances easterly and southeasterly in direction, moving out of their zones where they are created. They are comparatively small and they move very rapidly. And also the cold anticyclones have low thickness. They seldom develop beyond 3000 meters of vertical height, and they primarily originate in the northern Canadian Arctic region and moves towards the interior region of Canada and USA, bringing very cold chilly conditions to the interior of Canada and USA in the winter season. They also originate over Siberia, northern Russia, and then moves towards China, Japan and Alaska, bringing cold chilly weather conditions to these areas. So while entering the tropical areas or hitting the tropical boundary zones, while moving southward, they die out because primarily the tropical areas have high temperature, and once they hit the high temperature zones, these cold anticyclones, they die off because as the temperature increases, the pressure decreases and anticyclonic conditions have high pressure. So if you have increasing temperature, the pressure continuously decreases and these cold anticyclones, they gradually die off on hitting the tropical boundary zones of the world. So besides cold anticyclones, you also have warm anticyclones, and these types of cyclones are primarily dynamically induced and they originate in the belt of subtropical high pressure belt, where the high pressure is primarily induced due to the descent of winds from above and consequent divergence at ground, creating high pressure conditions in the areas between 30° north, 30° south in both the hemisphere. And the anticyclones in these areas is primarily associated with light winds, and they are mostly larger in size as compared to the cold anticyclones, but their movement is very sluggish, and sometimes they may also remain stationary over a particular area for a very long time period. And their vertical thickness is also immense when you compare them with the cold anticyclones, and they may extend vertically to 4 to 5,000 meters in the upper atmosphere. And these types of warm anticyclones are primarily seen in the southern USA and western part of Europe. So they are formed in the subtropical high pressure zones, and then they gradually move towards the polewards territories of the regions where they die off because of the presence of cyclonic conditions which exist polewards to these zones where they are formed. So while the arrival of cold anticyclone is associated with extremely low temperatures, with cold wave flashing during the winter season in the areas where the cold anticyclones exist, but when they arrive in summer in these areas and if they develop in summers, the weather becomes pleasant. Cold anticyclones also tend to migrate equatorwards out of the cold air mass regions and then eastward before decaying or merging with the warm anticyclones. So once they form in the very cold regions of the world and before merging with the warm anticyclones, they move eastward and equatorward and then they die off. While on the other hand, the warm anticyclones bring heat waves during summer season in the subtropical regions of the world. Because the subtropical regions of the world are marked by very high insulations, so anticyclonic conditions, if persist over the subtropical high pressure belts of the world, they create very hot conditions in these areas. But warm anticyclones also slowly migrate polewards with the warm season, and then while migrating northward, they gradually die off. So summarizing the video now, anticyclones are high pressure systems of the world with highest pressure at the center and gradually decreasing pressure towards the outer margins, because of which the wind movement is also from the central regions towards the peripheral region, and this wind movement is clockwise in the northern hemisphere while it is anti-clockwise in the southern hemisphere. These anticyclonic type of conditions are primarily induced because of the thermal conditions and also because of the dynamic conditions. So thermally induced anticyclones are primarily found in the polar regions of the world where the temperature is very low, and because of which the high atmospheric pressure prevail, leading to the anticyclonic conditions. But they are also formed in the region somewhere around 30° north and 30° south in both the hemisphere, and the formation of anticyclones in these mid-latitudinal regions of the world near the Tropic of Cancer and Tropic of Capricorn is primarily because of the dynamic reasons, where the winds from the upper troposphere, they sink, and while hitting the ground they diverge in the opposite directions, leading to the formation of high pressure belt in these zones, which are also called as high pressure ridges, and they are formed along the 30° north and south in both the hemisphere. And these regions of the world are marked by the divergence of winds which move away from the high pressure central region of these anticyclones. And these systems are extensive in nature with light movement of wind, and they are mostly associated with rainless, fair weather. Hence, they are also called as weatherless phenomena. And anticyclones can again be cold or warm, and they are associated with variable weather conditions, primarily in the tropical latitudes. So while the cold anticyclones impact the northern polar regions or Arctic regions of the world, the warm anticyclones are primarily developed in the regions of mid-latitudes due to dynamically induced conditions. And formation of many of the world deserts is one of the typical characteristics of anticyclones in the mid-latitudinal regions of the world, where the predominance of anticyclones show such weather systems where the precipitation regime and even the global wind circulation is affected by the occurrence by the dominance of anticyclonic conditions in these subtropical high pressure zones of the world. So I hope the video was informative, and this brings end to the module 6 of this particular video series, where we have thoroughly discussed various cyclonic conditions, anticyclonic conditions, formation of fronts, temperate cyclones, tornadoes, thunderstorms, and tropical cyclones in detail. So I hope the video was informative. Thank you so much.